solving linear equations, and a lot of this you should be good at. So if I go too fast, please say something and I will pause the video and slow down. But some of it really should be review at this point. 5x plus 4 equals 3x minus 8. Now before we start this problem, we should probably review what a linear equation is. When I talk about a linear equation, we're talking about one, sometimes it's written y equals mx plus b. That's called slope-intercept form, which we're going to talk about here in the next few days. But the main thing you need to know is that the highest power of x is 1. Okay? There's not going to be any x squareds in a linear. All right? So this is a linear equation. And of course, if we're solving a linear equation, don't I need to get all the x's on one side and all the numbers on the other? Right? So we use opposites. Subtract 4 from both sides. That's probably how I would start it. You could have added 8, but that's just what I did. 5x equals 3x. Now what's the rest of that? Minus 12. Be careful with those little algebra mistakes. Then I would subtract 3x from both sides. So I would have 2x equals negative 12. Divide both sides by 2, just doing opposites like you've done for a couple years. X equals negative 6. I went through that fast because you should be good at that at this point, just to get us warmed up. Let's do another one. Lots of different situations here. Sometimes, oops, that's just supposed to be an x, not a 3x. 6 times x minus 1 plus 4 equals 3 times the quantity, 7x plus 1. Sometimes you have to do what property first? Distributive property first. So I would distribute 6x minus 6 plus 4, and I would distribute the 3, 21x plus 3. Make sure you combine your like terms correctly. So I would have 6x minus 2 equals 21x plus 3. And then isn't it just like the last one from this point on? Okay? I'm not going to finish that one. Let's keep moving. You know how to finish that one. I'd like to get to some of these where there might be more questions, like this one. X over 3 plus 3x over 4 equals 2. Now, here's what I would do in this case. Fractions do complicate things a little bit, but I think the best way to do this problem is to multiply through by the least common denominator. Multiply through by the least common denominator. Why do we do that? Because it will get rid of those fractions. Hallelujah. Oh yeah, the J is the yeah, isn't it? Hallelujah. So what is the least common denominator of 3 and 4? 12. So watch what happens. If I multiply this, but let's do it on a separate step so you can see what your original problem looked like. 12 over 1 times x over 3 plus 12 over 1 times 3x over 4 equals 12. I don't have to put it over 1 on this side, times 2. Notice you have to what you do to one side of an equation, you have to do to the other. It's not an equation anymore if you don't do the same thing to both sides. Now watch what happens. I can get out the slasher. 3 divided by 3 is 1. 12 divided by 3 is 4. And now that term is a 4x. Boom, fraction gone. Plus 4 divided by 4 is 1. 12 divided by 4 is 3. 3 times 3x is 9x. Boom, fraction gone. 12 times 2 is 24. Fractions are gone. Looks a lot easier to me. Does that make sense to everybody? 4x plus 9x is 13x. No, you will not always have nice, pretty answers. Divide both sides by 13. Looks like x equals 24/13. It's okay to have an improper fraction every now and then. They need love too. All right. With that in mind, let's look at this one. 12 minus 5 over x equals 8 plus 6 over x. Guess what? This problem is just like the last one. I'm going to pause the video. You try it. All right, let's see how you did. You should have multiplied every term by x. X times the 12 minus x over 1 times 5 over x equals x times 8 plus x times 6 over x. Get out the slasher. Those go away. Those go away. And you now have 12x minus 5 equals 8x plus 6. Get all your x's and numbers together. Let's see, I'll add 5 to both sides. 12x equals 8x plus 11. Subtract 8x. 4x. Equals 11. Divide both sides by 4. Should have got 11/4. How did we do? Good? Now, like I said, there are different situations that you're going to run into, and this is one that really can save you time if you catch it. But you have to make sure what the situation is. This is written as a proportion, right? One fraction exactly equal to another fraction. Now, what if it would have had this maybe over here? Is it a proportion now? No. So you have to have exactly one fraction equal to another fraction. If that is the case, then you can rejoice and just cross multiply. Okay? Write a new equal sign. I'm going to have 2 times the quantity 8x minus 6, and I'm going to have 1 times the quantity 4x plus 3. Just a simple dedimple cross multiplication equation. So I'd have what? 16x minus 12 equals 4x plus 3. And I don't think I need to finish it from there. Okay? Finish normally. Okay? Now, the next thing. And this is where, I didn't want to have to rush through this next example. 1 over x minus 2, because you will see some like this in homework, equals 3 over x plus 2 minus 6x over x squared minus 4. This is still kind of a linear type equation, but it looks really, really scary. But we actually have all the skills we need to do this now. Now, just like the fraction problem a minute ago, we're going to use the same technique. We are going to multiply through by the least common denominator. By far, that is the best way to do this problem. So now we have to decide, what is the least common denominator? Well, if you remember, when we talked about rational expressions, which, by the way, will be on the next test, we need one of each factor. So I need an x minus 2. I need an x plus 2. And do I need anything else? I don't, because this is a difference of 2 squares that is x plus 2 times x minus 2. So this right here is my least common denominator. So I need to multiply each term by this. So I'm going to multiply x minus 2 times x plus 2 over 1 times the first fraction, 1 over x minus 2. Equals sign. Then I'm going to multiply the next fraction by that. X minus 2 times x plus 2 over 1 times the next fraction. 3 over x plus 2 minus x minus 2 times x plus 2 over 1 times that last fraction, 6x over x squared minus 4. And if you do that, then we can get out the slasher and slash away. Boom, 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 boom. Now I can mark out all of this. And now look what we have. I now just have x plus 2 times 1, which is just x plus 2. I have 3 distributed here, so that's 3x minus 6. Minus, be careful with these signs, 6x. And oh my goodness, does that look better. So you kind of have an ugly step at the beginning, but then you have a very simple linear equation from that point on. So we have x plus 2 equals negative 3x minus 6. I need to get all my x's together, so I will add 3x, 4x plus 2 equals negative 6. I'm going to come over here. 4x plus 2 equals negative 6. Subtract 2. 4x equals negative 8. Divide by 4. And I get negative 2. Now, if you got that far, I would be thrilled to death with all of you. There's just one little thing I want to point out, though. Your book sometimes will talk about something called an extraneous solution. What the heck do they mean by that? Well, in this case, if I look at that negative 2, and I look at my original equation, what happens if I put that negative 2 into this fraction? Don't I get a 0 in the denominator, which is a problem? You can't divide a number by 0. So it's technically not even really a solution. It's what's called an extraneous solution. So if you're checking your answers in the back of the book and you see this phrase, extraneous solution, it's just because when you plug it into the original equation, you get a 0 in the denominator. Okay? So if you get the negative 2, I'm thrilled to death with what you did. All right? Now, the hard part's over. What if they ask you to find, you know those x and y-intercepts that we've been talking about the last couple days? What if they ask you to find those algebraically? It's very simple. And I want you to understand the reasoning behind this, and this is the way that I keep them straight. If I think of a y-intercept and an x-intercept, what is the x-coordinate of this y-intercept? X has to be 0 here. What has to be true here? Y has to be equal to 0. So there you go. There's your rules. If I want to do this algebraically, all right, if I want to find a y-intercept, okay, then you set the x equal to 0 and solve. That's to do it algebraically. If I want to find the x-intercept, I do the opposite. I set the y equal to 0 and solve. It's that simple. So if they give you something like this, if they tell you to find the x and y intercepts algebraically, we'll just do one of these. And they give you an equation like 3x over 4 plus 7 minus 2y equals 0. This is actually pretty simple work, because if I want to find, let's do the x-intercept first. If I want to do the x-intercept, then I'm going to replace y with a 0. Okay? So I'm going to have 3x over 4 plus 7 minus 2 times, instead of a y, I'm going to put a 0, equals 0. And then you just solve it. So let's see, 2 times 0 is 0. Okay, so this goes away. So now I have 3x over 4 plus 7 equals 0. How would I finish this problem? I'd go ahead and multiply by the least common denominator. Get rid of that fraction. That's what I'd do. I'd multiply everything by 4. 4 times this, 4 times this, 4 times this. Because that'll get rid of my fraction right now. Watch. Gone. So I have 3x plus 28 equals 0, and you finish solving it. Okay? That's the way I would finish that problem. 3x equals negative 28, x equals negative 28 thirds, and that is your x-intercept. Then you have to find the y-intercept. So to find the y-intercept, we set what equal to 0? The x. We're going to like this because it's going to make this fraction go away. Okay, as soon as I put that 0 in for x, that whole fraction is gone, because 3 times 0 is 0. 0 divided by 4 is 0. So that thing's gone. So now I have 7 minus 2y equals 0. Subtract 7. Negative 2y equals negative 7. Divided by negative 2. Y equals 7 halves. Pretty easy algebra after that point. Now, I also want you to turn in your book and look at page 93, number 5. Now, I'm not going to write out everything from this, but what they do is they are giving you a linear model of data. Okay, there's my linear model, and then they tell you this thing, okay, that t has to be between negative 1 and 12. That's all that says. All right, this is the number y in millions of female participants in high school athletic programs from 1989 to 2002, where t equals 0, is 1990. That's pretty important. And then they tell you to find two things. A, find the y-intercept of the graph of the linear model. Isn't that easy? How do you find the y-intercept for this? What did we just say? Put in a 0 for x, right? Well, in this case, it's going to be t, right? So you would just put a 0 right here and solve. That's how you would do part A. I'm not going to do that. Okay, that's easy. Part B. Look at part B. Assuming that this linear pattern continues, find the year in which there will be 3.36 million female participants. Well, y is the number of participants. Okay? Y is the number of participants. So what I want to do is replace y with a 3.36 and then solve it. Okay? So you'd solve that simple algebra equation, I'm going to tell, because of the sake of time, I'm going to tell you that t winds up being 18. Okay? Once we do our algebra and solve that. So what's the answer? What year? Well, if t equals 0 is 1990, then t equals 18 would have to be 2008, right? You just add 18, all right? So we're going to stop there for today.